Hey mathletes, this last section we're going to take a look at rational domains. And the domain of a rational function is that x cannot equal 0, and this is because the denominator here, we can never have a 0. The numerator I do not need to worry about unless the numerator itself has its own domain restriction. So since x is not equal 0, this is what it would look like as an interval, negative infinity to 0, and then 0 to infinity. So let's take a look at this next example. The denominator is the only thing I need to worry about because the numerator itself doesn't have any restrictions. So I'm going to set 4x minus 9 does not equal 0. I'll add 9 to both sides and divide both sides by 4. And so I have x does not equal 9/4. Now, again, on a number line, I will plot 9/4. It's an open circle, and everything else is okay. So shading both to the left and the right, and as an interval, negative infinity to 9/4, and then 9/4 to infinity. Here's the graph, and we can see right here we have an asymptote right at about 9/4. And finally, we're going to take a look at multiple solutions with rationals. So I have this function, f of x equals 2x minus 3 over x squared minus 3x minus 10. Now again, the numerator is 2x plus 3. That parent function is actually just a line which has no domain restrictions. So the function itself, I only need to worry about the denominator. So I'm going to take that denominator, 2x squared minus 3x minus 10, and I'm going to make that not equal to 0. It's not equal to 0. Now this is a quadratic, and in order to solve a quadratic, I'm going to need to either use the quadratic formula or see if I can do some factoring. So multiplies to negative 10 and adds up to negative 3 would be a negative 5 and a positive 2. So this polynomial, x squared minus 3x minus 10, will factor to x minus 5 times x plus 2. So both of those factors do not equal 0. And using our zero product property, x minus 5 will not equal 0, or x plus 2 will not equal 0. In solving both of those, we'll get x does not equal 5, or x does not equal negative 2. So these are my two solutions. I'm going to go ahead and plot both of those, negative 2 and positive 5. So then, since I cannot use those values, I'll have open circles there, and anything else is fair game. So I will write my inequality negative infinity to negative 2, and then I have another piece from negative 2 to 5. And then my final piece is from 5 to infinity. Now I do want to make a note and make sure you guys are aware. In this example, it's x squared minus 3x. Because we have two x's, I do need to use some sort of a factoring. If it was just x squared, like we had on previous problems, I can just go through a square root approach. So let's take a look at the graph. Here's the graph, and we can see an asymptote at negative 2 and an asymptote at 5.